Hey, Math 126 fans, back at it here. Questions being asked on my discussion board about parameterizing curves. Now, I have several videos on this. This is from section 13.1. So if you search my YouTube channel for surface of motion is what I would call something like this, you will find a couple videos where I give a full explanation. But let's try to give a short version here. So remember, when you are trying to parameterize, you're trying to describe the intersection of those two things. You have given a lot of freedom. You can pick anything you want for x, for y, and for z. The only rule is that whatever equations you pick have to always work in those two equations, meaning whatever this is, if you put it here, and whatever this is, if you put it here, and whatever this is, if you put it here and here, this will always be 9 for all values of t, and these two things will always be equal for all values of t. It's not enough for just one. So the person who asked this question, they picked two kind of random points from the intersection, and they found the equation of the line between those two random points. That's not going to work. So here's the line they were proposing. I made it too thick there. That line does not describe the intersection. The intersection we're trying to describe is this. That line it has one point that's on there, but it does not describe that intersection. It only works if it works for one t. That doesn't work at all. So you can't assume it's a line unless it's the intersection of two planes. So we need to describe that. Okay, we have two strategies, and they're both valid. One strategy is to randomly pick one of the variables to be t, which is not the best strategy here for computational reasons. But for example, you could pick z to be t and see where that leads. That's going to mean that y has to be 10t squared. And then you could try to solve for x. That's going to get a little messier, and that's why this is an undesirable parameterization. But let's keep going. This would be t squared equals 9. Then you would solve for x. You would have x minus 2 squared equals 9 minus t squared. You'd have plus or minus the square root. So I think it's going to be 2 plus or minus the square root, 9 minus t squared. And I didn't even set this one up, but that's a valid parameterization. Unfortunately, it splits it into two parts, the positive and negative. If I were to animate it, I can do that. So I would have 2 plus the square root of 9 minus t to the second, comma 10t to the second, comma t. And you would have a restriction. So I think at has to be between -3 and 3. And you could let it go. You can see that little animation, that dot on there. So that would work, but you'd run into a problem is it would stop. It would only do half of it if you didn't do the plus and minus. Watch it, you can see it stops. And then it comes back. So that only parameterizes half. If you put the plus and minus in, you do get both, but then you need two different parameterization, the plus and the minus. Okay, so that was that story. So that was one way to do such a problem, but we said if there is a circle involved, there is another way. Try to use a circular parameterization. And this thing does look like a circle from the side. So let's parameterize that circle. The standard way we parameterize the circle is we have this be cosine, and we have this be sine. Now, because of the 9 on the other side, this has to be a 3. This has to be a 3, so that when we square, we get 9 cosine squared plus 9 sine squared, which will be 9. So I need x minus 2 to be 3 cosine, so that means that x is going to have to be 2 plus 3 cosine. If you need that broken down further, you would say whichever is in the parentheses needs to be 3 cosine, and then you would add the 2 to both sides. Then we need the z to be 3 sine. And the moment I do that, it's going to be circular motion. So let's actually parameterize the entire circle now. And let's plot the point. So this is going to go all the way around if I go from 0 to 2 pi, and then it's just going to repeat. So let me animate that so you can see it. So from the side, this is just going to be circular motion, standard circular motion that goes at a constant speed and completes one lap every 2 pi. In addition, I want the other value to change appropriately. And the other value is going to be 10 times whatever z is squared. And this is what z is. So just for a quick example, if I made z, if I made y 0, I'm just going to do that real quick. And then I turn this, you would see that it is circular motion, but it's not on there. The moment I replace the y value with 10 times 3 squared, so times 9, so 90, sine squared of t, then it's going to make the third value change appropriately like this. And that parameterizes the whole thing. So from this side, it's circular parameterization. From the other side, the y value is changing appropriately. There we go. So that's, and it does one full loop from 0 to 2 pi. So there's yet another sort of breakdown of that story. I hope that sort of helps. So it's going to be 90 sine squared of t. And there are other correct answers too. I just gave you 2. All right, let's just stop there.